CSIS 2470 is filmed before a live studio audience.
Hey everybody, welcome to class. Today we're going to be talking about objects. What the heck is an object? Why do we care? And all that fun stuff. Now we've already dipped our toes in the water of objects. We've talked about the constructor function, which is sort of a introduction to objects. And if you want to know more about that, go back to the advanced function video. We also even looked at an object literal when we were talking about parameters in functions. So we'll get to that in just a moment. But first, let's define what the heck is an object. The simple answer is this. It's a thing, right? Just like in the real world, everything's an object, right? Your desk is an object. Your computer is an object. You could even argue that your pet or you yourself as a human, you are an object, right? Everything that we look at is an object. And so in code, it can be very useful to model things after real world objects. So as usual, the best way to figure this out and understand it is to take a look at it. So there ain't nothing to it but to do it to the code. All right, so right now we just have a blank screen here, and I'm going to give you just a little example of an object literal, which we kind of talked about, as I mentioned, in the functions video. So let's just start there. We're going to model a dog, right? A dog is an object, and we're going to model specifically my dog. And my dog's name is Pluto, just like Mickey Mouse's dog, right? And so we're going to say, let Pluto equal, we're going to make it be a bunch of things, right? Normally when we do something like this, we don't put curly braces there. We say banana, or we say 5, right? We create some variable, give it a value. Well, in our case, the value is going to be a bunch of stuff. We're going to care about the dog's age, and the dog is 7, comma, name, and it's Pluto. And we're going to say, well, that should be in quotes, of course, because it's a string, Pluto. And we'll say the dog's color is speckled. It's like 20 different colors. And for now, we'll just use name, age, and color. I mean, obviously, there are lots of other things related to dogs, right? There are, maybe we care about the eye color, or we care about the height, the weight, and all these other things. But for our simple dog, we're not going to model every little aspect of it. But keep in mind, that is the idea of an object. You are able to model every piece of it. And so right now I have in this little Pluto variable, it's like a ball of stuff about Pluto, the dog, right? And in fact, my dog can speak. So we'll make a function called speak that returns bark. That's what my dog does, bark. So every time we ring the doorbell, we activate the speak function. Okay, that's my dog. Pretty simple, straightforward, but now Pluto is this big object that has all kinds of things in it. And again, as I mentioned, if I wanted to get more depth here, I could say height is like, I don't know, he's about 2 feet off the ground. And he is, we'll go with length, I guess. Like he's about, I don't know how long he is, 2 feet, I guess. Whatever, I have no idea. And his weight, we'll just do one more property here, weight. And he is like about 15 pounds or something, a little bitty thing. I don't know. So that's the dog. Now, if I want to access anything in the dog, I can say console.log, for example, Pluto.age, right? If I do that, it's going to go, okay, give me the Pluto object, give me its age, right? And so it'll give me that value 7 right there. And if we go back to the browser and I refresh, we get an error. Let's go see what's causing the error. And it is on line 8 right there. We need a comma right there. I know that's a little weird, but each of these things are parts of the object, and so they need to all be separated by a comma, even though that's a function. It seems a little weird, but that is the way that's got to be. So we refresh now, and there I get 7, right? So Pluto.age is 7. If I said Pluto.color, it would print out speckled, right? And if I said bark, and that's a function, bark, sorry, not bark, but speak, and we refresh, it says bark. That's an object literal, right? It's a pretty simple idea, and it can be very useful, and I'll actually show you in a bonus video a use case for something like this. The problem with this, however, in this particular case, not the use case I'm going to show you in the bonus video, but in this case, it can get a little bit crazy, because what if I had another dog, right? And that other dog is a dog I used to have when I was a kid called Bingo. And now I have a whole new, I got to copy all this stuff over again, right? I got to copy all of this, put in different numbers here. Bingo is 3, Bingo or Jingo, sorry. And Bingo was Heinz 57. That's a sort of a color. It's kind of breed he was, right? Which, by the way, that's another thing we could capture here is breed. And so now that I've thought of it, oh, we have to go add it, right? Here, breed. And what kind of breed is, he's a Chihuahua, right? All right, don't forget the comma. And then let's go height is 4, and I'm making up numbers, right? I'm just making stuff up here. But they would be different theoretically. It would still return bark. But now I have to add breed, right? So I can add breed in here, and it was a mutt. Bingo was a mutt, right? So now I have Bingo represented here, and I can do things with Bingo. Bingo dot breed, and when I refresh it, it says Bingo was a mutt, right? Now you can see how this can quickly get crazy out of control here if I had 3 dogs. And what I'm about to say, you're not going to believe me, but this is true. When I was a kid, there was a point where we had over 20 dogs, right? What happened was we had about 4 or 5 female dogs, and they all had litters, right? And so there's just a whole bunch of dogs all over the place. Maybe it was like 3 dogs, but they all had, 5 or 6 in each litter, and we had something like over 20 dogs. And so if I had to keep all these in here, this could be super messy. Well, to solve this problem, we use what's called a class. And we've already kind of looked at the beginnings of a class in JavaScript when we talked about constructor functions, right? I'm not going to rehash what we did there. Again, if you want a refresher on that, go back to the advanced functions video where we talk about it briefly. And it is brief in there, and we don't need to get into too much detail. The detail in that video is enough, because what we're about to learn is the new way as of ES6. And this new way is very much like what it's like in most other object-oriented languages. It's a little different though. There are some weird little quirky things, and we'll get to all those. But for now, let's convert this into a class so we can sort of genericize things, if you will, right? So I'm going to keep this Pluto and Bingo for a minute, and let's make a class called dog, right? Now notice that the dog is capital D there. That's not required, but it is standard practice to do that. So just do it so that everybody knows it's a class, right? Okay, so basically we want all of these things in there, right? We want age, name, color, all that stuff in here. So age, and then name, and then color. And I'll explain this in just a minute after I do the copying and pasting, which I'll probably speed up in post. Weight, breed, and we'll take care of speak momentarily. Now look what's happening right here. What a class is it's like a cookie cutter or a blueprint, if you know what that is. Well, let's start with a cookie cutter. I think everybody knows what that is. So imagine you have like a gingerbread cookie, right? They're all pretty much shaped the same way. And you take that gingerbread cookie and you got a big roll of gingerbread rolled out in front of you that hasn't been cooked yet. And you take your cookie cutter and you stamp out a little gingerbread guy, right? And then you stamp out another one, and then another one. And so now you have like 5 or 6 gingerbread guys. They all look exactly the same. You bake them, and when you're done, they all look the same because they came from the same cookie cutter. But then you decorate them. Well, when you decorate them, you change the color of it, or maybe you put a little bow tie on one of them, or maybe one's got more beady eyes than the other, or maybe you put a couple little dots to make it look like buttons, or you make a scarf on them, and they all look different. Well, that's what we're going to be able to do with this class object, or this class model, I should say, right? We'll be able to do that here, and we're going to walk through it in just a second. The other thing, the blueprint example, for those who are, I'm going to say under the age of 25, and you're not 100% sure what a blueprint is, it's literally a big, ginormous blue piece of paper that you roll up, and this was how houses were designed a long time ago, and maybe they still are this way, I don't know. But an architect would sit in his office with his drafting table, and he would draw on a piece of paper the design of the house. I mean everything, like where the electrical outlets go, where the bathroom is, where the door is, where the windows are, where the toilet goes, where the sink goes, where the kitchen cabinets go, where like everything, it's just all there. Then the construction workers would go to the job site, a big empty lot, they roll out the blue piece of paper, put some bricks on it so it doesn't blow away, and they look at it and they build the house based on the specs of the blueprint. And then they go 3 doors down, roll out the same blueprint, put the bricks on it, and build that exact same house, right? So if you've lived in a neighborhood, where they have tract housing, or any sort of suburban area where every 3rd or 4th house is the same, That's the idea here. They have this, they call them cookie cutter houses, but there's just the same blueprint being used multiple times on every fourth house. And then, so that's the first house, the fourth house, the eighth house or whatever. But then house number 2 and number 5 and number 9, it's a different blueprint, right? So that's the idea here. We're making a blueprint for how to make dogs. Line 1 through 10 is the rule book on making dogs, or the cookie cutter for cutting out dogs, or the blueprint for making dogs, however you want to look at it. All right. Now, when you think through building a dog, you got to think about all the things that a dog has. These are all of the properties, right? A dog has an age property. It has a name property. It has a color property, right? Everything around you that you can think of has these properties. I'm looking at my desktop computer here. It has a color property. It's black. It has a weight property. I have no idea what it weighs, but it's got some weight. It's got dimensions, height, width, length, all these things, okay? So I'm thinking about dogs, and they have ages, they have names, they have colors, height, length, width, or weight, whatever, breed, and there's probably 1,000 other things I could think of, but we're going to leave it at that. And so that's the properties of a dog. But they also have things they can do, right? A dog can speak, a dog can run, a dog can sit, right? And any time, if you've ever trained a dog, they can sit, speak, roll over, play dead, all these different things, right? So for all of those things, you would need to make what's called a method. That's the fancy word for it in object-oriented programming. But all the method is, it's just a function, right? So we've already seen we have the speak and it return bark, and maybe we'll just have an eat function and return the dog saying yummy, and we'll have a sit function saying sitting like a good doggy, right? And we could go on with what all these different functions do, but this is a good starting point. Okay, well now, right here I have Pluto. I have to make Pluto, and I have to make Bingo, right? So the way we do this now is, instead of saying let Pluto equal all this bundle of stuff, I say let Pluto equal a new dog, right? And then I'm going to block out all of this for just a minute. Okay, I'm saying let Pluto equal a new dog. What just happened now was this line of code right here goes, oh, I'm supposed to make a new dog. Well, where's my rule book for making dogs? Where's my blueprint? Where's my cookie cutter? Oh, it's this code right here. That's how I make a new dog. And so now blocked out in memory is whatever is necessary to hold all of this stuff here. Okay, now we need to, once we've done that, give the color a value, give the age a value, give the name a value, and so on and so forth. So because of that, and because we're going to be doing this over and over again, I'm going to cut down the number of properties we're dealing with here, right? I'm going to skip breed, weight, height, length, and maybe we'll keep breed. We'll just do these right here, right? Now, obviously, the list of properties could be way more than they are, way more than they even are down here in green. But for simplicity, I don't want to have to repeat and duplicate this whole thing again. So we're going to skip all that. But we still need to create this part of it, right? So it looks like this. Pluto.age equals 4. And then Pluto.name equals Pluto. I know it's a little weird and redundant, but that's okay. Pluto.color is speckled, and Pluto.breed Chihuahua. That's how I remember to spell it. Okay, now, had I kept all the other things in there, height, width, all that stuff, I would have to also create those. But I'm going to skip all that. We're not going to bother doing that, and we're just going to make our dog a smaller set of properties, right? Just for simplicity in this video. So now let's look and see what happens here. If I say console.log Pluto.breed, it should say Chihuahua, unless I get an error, which is entirely possible, but it says Chihuahua. Now this bark and mutt business is all this stuff down here, so we'll just comment that out for a minute. So you can see this whole thing now, line 13 through 19, worked to do what we were kind of doing before, right? And if I wanted to see the dog speak, refresh, and the dog's barking. If I want the dog to sit, the dog sits, sitting like a good doggy. Okay, but you can see that this is just as long as this, right? Especially if I continued with all of these other properties here. So how does that help, right? Because I'm going to have to make let Bingo equal new dog and do this exact same thing again, which is kind of silly. So hopefully that makes sense, that we haven't really fully made this as efficient as we want it to be, right? but we can do that. What I want to do is be able to, when I create Pluto, hand off parameters to the dog class. Hand the 4, the Pluto, the Speckled, the Chihuahua right here to the dog class. But looking at it right now, where the heck would they go if I did that, right? So if I put 4 right there, comma Pluto, comma Speckled, comma Chihuahua, well, where the heck would they go? Well, right now they'd go nowhere. So what we need to do is add a special function to our class called a constructor. And it's just what it sounds like. It constructs the object. And so right now on line 13, we are creating an object based on this class. Or remember, class is another name for cookie cutter, right? Or blueprint, right? And so this is the class. This is the object. When I create the object, which right now line 13 won't work. We're going to make it work in a minute. But when I create the object, I'm what we call instantiating it. I'm creating an instance of it, right? And so we need to pass in these parameters to the class and construct this object. So right here, we're going to make a function called construct. So the constructor will take in 4 different parameters, right? And so they're going to be age, name, color, breed. Now this age and this name and this color and this breed are not this age, this name, this color, or this breed. Okay, these are 2 different variables. These are the temporary variables, if you will, that are going to handle these 4 arguments down here. Okay, in here I need to get this age and set it equal to that age. And so you literally say this dot age equals age. That age right here, this age is this one, and this age is that one, right? So then we go with this dot name equals name, this dot color equals color, color depth, and this dot breed equals breed. So now when I run line 19, it's the same thing as if I ran all 20 through 23 lines as well. So let's change this. We'll go sit, and we'll also get the age here. And now we said the age is 4. We passed off that age to this constructor right here. And so now that's 4. And so we're setting this value 4 to this variable, which is this guy right here. Okay, let's run it, and it should still spit out a 4. And it does. And he's also sitting like a good doggy because of line 26. Okay, so now I don't need all that there. Now look how clean it is to create a little doggy. Well, now I can do the same thing with bingo, right? Because now I have this constructor, so I can say let bingo equal new dog. Bingo is 5. Named bingo is colorful. We'll go with that. And is a mutt. That's it. That's all I need to do. I don't need any of this down here anymore, right? It's all taken care of. And again, just one last reminder. Of course, if the object is going to be tracking all these things here, height, length, I would have to put them in here and add them to the constructor and everything, but I don't want to make this dog class too huge, so we're going to just keep it simple here, like so. Okay, so now I have 2 new dogs, and I can print them out or do whatever. So we'll get Bingo's age. Bingo, we'll tell Bingo to eat, and when we refresh, this is 4, which is Pluto's age, sitting like a good doggy. That's 5, which is Bingo, and Bingo is eating. Way cleaner code, and I can make a ton of these, right, for a whole bunch of different new dogs with different names, okay? But what's happened here is we've simplified it by creating a template, right? That's another name you'll hear these called, a template, okay? So this is the basic idea, but wait, there's more.
But I'm not done yet.
But I want to make sure we're feeling okay about this part. So take a moment, look it over, make sure you understand the basic idea of what's happening here. Now you'll also notice one other weird thing. Normally when I make a function, I have to type the keyword function, but these don't have that. And normally when you make a variable, you have to say let or const or var or something, but we're not doing that. That's because we're inside of a class, and we're basically taking the square peg of a variable and we're sticking it in the round hole of a property, right? And so we're adapting the use of variables to become what we call properties in classes. And the same things with the function. We're adapting what we call functions to be methods inside of a class. And so we just have a little bit different syntax, that's all.